let's see. So let's start with number one. Number one, it's a trapezoid, so you're just finding the area of the trapezoid, and then so we just find that the base is 4, or the height is 4, and then the bases are 11 and 5. So one of them is going to be length 5, one of them is going to be length 11 here, and then we just use the trapezoid formula to find the area. And then at the end, we're just saying, what's the distance traveled? That's what the problem was actually asking. And I saw that this was velocity was in meters per second. So we said it was 32 meters traveled. And then for problem 2, it's a triangle. So I'm going to use the triangle formula, 1/2 base times height. But I got to find this corner of the triangle first. So I just plugged in values. So I plugged in 4 for t, and I got 3 as the height. I plugged in 3 and I got 2 as the height, 2 and I got 1 as the height. I plugged in 1 and I got 0 as the height there. So that's how I found those values. Okay, so that's how I ended up getting 3 and 3 is the base and the height for the triangle. Okay, I'm going to give you guys a few more minutes to work on the other 3, but that's just to get you started if you were stuck on them. Alright, so for problem 3, we should be able to plug in 0 for the x value, and you're going to find the y value, which turns out to be 9 when you plugged in 0 for the x value. When you plugged in 0 for the y value and you solve for t, or the x value, you get 3. And that's how you get your base and height for the triangle there, and then you plug into the triangle formula. Alright, problems 4 and 5, the last two are a little bit trickier because you've got, it looks like you've got some weird shapes. So you have to be a little bit creative in them. You could do it a few different ways. You could split it into maybe a rectangle and a triangle, like maybe that's how I would do problem 4 there. And problem 5, maybe split it into a trapezoid and a rectangle. All right, so just have to be creative on problems 4 and 5 with how you're going to split it. On problem 4, for example, the first thing I would look at was, the first thing I was thinking about was like, oh, I could split it into 2 trapezoids. So I mean, you could do something like that. That's perfectly fine. Okay, but I think a triangle and a rectangle is perfectly fine as well. So it really just depends on how you want to split it for those last 2 problems to solve. Okay. Actually, I think the 2 trapezoids might be better because there's no guarantee that these are ending at the exact same place down here. So the 2 trapezoid method will probably be a better one than the triangle and rectangle method. Okay. And then we just have to find the certain locations once we set these up. So in this one, for problem 5 here, I see when y equals 6, I'm going to get that intersection. So I'll subtract 7 and I get x equals -1, or negative x equals -1, and then I divide both by 1, so I get x equals 1. So this is happening at x equals 1 right there, where that split is. So now I know the distance here is 4, and the distance here is also 4. That's the height of my trapezoid, and we know this height is 6, and this height is 6. And we'll need to plug in when x equals 5 to find the other one. So f of 5 to find this height right here. -5 plus 7, 2. And now we've got our areas that we can find. We start with the rectangle, base times height, 6 times 4, 24. The area of the trapezoid, 1/2 base 1 plus base 2 times the height, which is 1/2 of 6 plus 2 times 4. Which is another 16. And then the total area, 24 plus 16 is 40. And there's no units given, so we can just say 40 units squared. All right, that'd be for problem 5. For problem 4, I would need to start by plugging in 0 for x on the g of x. And I'm going to get 3. All right. And then to find this intersection here, I'd have to set those two equations equal to each other and solve for x. So we have to be kind of smart about how to do this. Find out when do those equations intersect. All right. And then I get 2x plus 3 equals 7. Subtract 3 from both sides, 2x equals 4. Divide both sides by 2, and I get x equals 2. Perfect. And then when x equals 2, I could find the height. I just have to plug in g of 2 here. And it would be the same answer for both versions. 3 plus 3, it should be 6. So there's a lot going on there to get that first trapezoid. We know the bases are going to be 3 and 6. The height's going to be 2. And then we can find the second trapezoid by plugging in 8. And that height comes out to 3. So yeah, there's definitely a lot going on for these ones. And now I can find the two trapezoids once I have all that information that I found. And I can go ahead and find the total area here. So they can get a little bit tricky here, these types of problems. But we have to be good about following through and saying, what's it asking? How do I find intersections? It's a lot of just kind of piecing it together. A lot of different math skills used here to find this area. And then the first trapezoid, 1/2, 1/2 3 plus 6 times 2. The second area, 1/2 3 plus 6 times 6. And the first one's going to be 9/2 plus 2, 13/2, just 6.5. The second one's going to be 9/2 plus 12/2, which is 21/2, which is 10.5. So I get 6.5 plus 10.5, and we end up getting 17. So the area of the second one, I should have 17 units squared. Hopefully that's what you guys got too. I haven't double checked this one yet, but there's a lot going on for problem 4. That's probably the trickiest one of all 5 of these. Trying to find all that information for both the trapezoids and then using that to get our final answer. So that was a parabola that was going to look something like this. X squared plus 1. And then we were going on the interval from 0 to 2. And we were looking for this area under the curve. And remember, we did the rectangle method on Tuesday with that problem where we said, let's go ahead and do rectangles. And we did it with like 4 rectangles, and then we did it with 6 rectangles. And then we looked at 20 rectangles, 50 rectangles, 100 rectangles. And ultimately we got closer and closer to the area. We did the lower bound rectangles, the ones that started on the left side, and did a little underestimate, and then the ones that started on the right side did an overestimate. And we ended up honing in on that the final area was 4 2/3 or 4.67 if we round it. Okay. So what we want to do today is we want to put this into our calculator. And basically what a calculator is doing when it's asking you to find the integral, an integral is undoing a derivative. So this is really kind of weird. I'll show you how to do this by hand first, which you do not need to know how to do it by hand, but I'm going to show you anyway. So whenever you're undoing an integral, what you're going to do is you're going to write down a bar. It's been a long time since I've done this. This looks like this. And you're just going to take the lower limit and the upper limit, write 0 and 2. And then you have to think about, how do I do this as a derivative? So it's basically the opposite of a derivative. So whenever we're doing a derivative, like let's say if I was doing x cubed plus 3x squared plus 5x plus 1, we would drop this number down, and then we'd write it as 3x squared. And then we drop this number down and write it as 6x and to the first. And then we just drop a 1 down, and then this final one just kind of goes away. So what's going to happen with undoing a derivative, we're going to add a plus c at the end. And the plus c stands for constant, because there was a constant up here that went away when we took the derivative of it. So when we're doing an integral, we add a plus c to represent that constant that goes away when we take a derivative. It's kind of weird. So what happens then, I started with an x squared here, and I'm doing an integral, so I want this to be an x cubed. And I want to think about, when I'm taking the derivative of this x cubed, I want it to be a 1x squared, because that's what's here. So think about if you're taking this x cubed and I drop the 3 out front, I'm going to get a 3x squared, not a 1x squared. So I need to put a number in front of that x cubed, so that way this becomes a 1 when I take the derivative of it. It's a lot. So what I'm saying again is, when you're taking the derivative was hopefully pretty easy for us. But right now, if I'm trying to do the integral, which is like undoing a derivative, I have to think about, there's got to be a number out front here. And it turns out the number I want to put here is 1/3. And that's because if I have 1/3 x cubed, and then we'll just say plus x here, plus x, and I say let's take the derivative of that, I'm going to do 1/3 times 3x squared, and then the derivative of x is just 1. And it was a plus c, the c goes away, then that's how I would take the derivative. And I would get 1/3 times 3, that just gives me an x squared plus 1. Again, I am not asking you guys to do derivatives or integrals by hand. I'm not asking you to do that. You will not be expected to do that on the IB exam. I'm just showing you this is how it works. Okay? And then we would evaluate the integral from the upper limit and the lower limit, because remember, it's finding the area. So basically what's going to happen is it's going to say, hey, let's do the area. It basically uses the y-axis is kind of our limit spot right there. And what you're going to do is you're going to say, hey, let's do the area of the upper limit first, which is 2 in this case. And you would plug in 2 to the integral. And then the c is just going to be there. And then you subtract your lower bound limit, 1/3 times 0 cubed plus, 0 plus c. That's how you would do this. And what it's doing basically is, normally, let's say you have an area that's, I'm going to draw a different one here. If it's like from 1 to 3, what happens is when I find the area of the 3, the upper bound, it's going to find this whole thing. And when I do the area of 1, it's going to find just this yellow part. So the whole purpose is when I'm doing 1 minus the other, I'm going to be left with the area in between the two numbers. That's the idea that's going on here. So that's the tricky part. Oh, did I lose you guys? Hopefully you're still there. Okay, good, you're still there. So that's the idea that's going on here. So for this problem, technically, I don't even need to do the second part of the integral. I could just say, well, we don't need to worry about that part. And we just know that c is non-consequential. That can kind of go away. And I end up getting like a 1/3. That only works, by the way, because this number was 0 down here. It only works when the bottom number is 0. I end up getting like a 1/3 times 2 to the third. So that's going to be a 1/3 times 8 plus 2. 1/3 times 8 is 8/3. 2 is a 6/3, which becomes 14/3. If I do 14 divided by 3, I get 4.67. There's my integral for example 5. Really weird. Like I said, I'm not expecting you guys to do that by hand ever, but that's just what integrals do. That's how you calculate them, and that's how you find them by hand. The opposite of a derivative. It takes a lot of practice to get good at that. But instead, we can put that into our calculator and save ourselves a lot of time. And that's what we're going to do. I did put the calculator instructions. There are calculator instructions for all of examples 5, 6, and 7 available on the Canvas page. There are 2 ways to do the integral in your calculator. One of them is you can actually find an integral button and type this thing in exactly as it is. The other way you can do it is by graphing and finding the integral on your graph. Okay, so you can do either one of those methods here. And let's go ahead and take a look on Canvas now. All right, so for example 6, that's what we want to look at for simplifying it. The final one, example 7, this one says the area of the region bounded by the graph f of x squared plus 3, the x-axis, and then it gives us the vertical lines x equals -1 and x equals a, and just says a is greater than -1, and it gives us the total area. So this one's kind of like a work backwards problem. We can set up the integral and say the integral is going from -1 to a, and the equation is x squared plus 3 dx, and that equals the total area of 12. That's what's happening in example 7 here. And we need to find the value of a.
I think your work just disappeared. Either that or my thing is being merged. On example 6.
Yeah, you're right. I think I must have hit the undo button on it. Let's see. So, yep, sorry about that. So let me write it again. Yeah, I must have clicked the undo button because I'm left-handed, so I just hit it.
Oh, that's a party foul.
Party foul being left-handed. Thanks.
No, that you hit the undo button, not you being left-handed. I'm not roasting you for being left-handed.
Okay. Okay, so 0 to 3, and then -x times x minus 3, it should equal 4.5. So for example 7, there's a way to do this by hand to solve for a. I'm not going to waste your time with that. For this one, you're going to want to do this one in the calculator as well. And what you can do is you can plug it into your graphing calculator. All right. And you'll have the default axes set. And we're going to want to look here for, let's see, total area of 12. We should be able to use an equation solver for this. All right, so it says I don't know. I've never done this on the calculator before, so on this one it just says press math and then B solver. I would say just follow the example for this one. Yeah. Sorry, I'm being a little lazy today on this last problem. Like I said, because I can show you how to do it by hand, but it's going to be more confusing than when I showed you to do the integral on example 5. And again, you don't need to know how to do this by hand, you just need to know how to put it in your calculator. So you're going to be using the solver button to do it, the equation solver.
I respect it. You're saving us time and energy.
That's
So,
the
you
goal.
know,
That's the goal.
bonus
Yeah.
points to you.
Sort of. For being lazy and not not teaching you how to do it by hand.
It's
know.
fine. We'll learn that later.
Yes,
This-
when you take
This
calculus
tells
in
us
college.
how to do it.
When you take calculus in college, you will definitely learn how to do this all by hand. This is just a quick introduction to it. All right. And
Hey,
yeah,
but for now, we get to use the calculator, and that's
Sure.
great.
yeah, and one of the weird things about this, because integrals have never been on the IB exam before for you guys. This is the first year because this is a new course. So I can't look at past IB exams and see integral questions, so I have no idea what they're going to ask you. I can just assume that the book is leading us in the right direction here, that we're going to use calculators for all of this. And so the book makes the emphasis on kind of what's going to be expected of you on the exam. So that's just my disclaimer there, that I don't know what type of integral questions will be asked on the IB exam. With everything else, I have a good idea, but with integrals, I don't, since this is new material for us. Okay, so that takes care of example 7, solve for A. And you can always verify it, because once you get the A value, you should be able to plug back in and double check it. Okay, so it's the x squared plus 3 dx. And what do we end up getting for this one? Yeah. Does it come out to 3? Is the x value 3, I think? Yeah. There we go.
So what do we put in our calculator?
Oh, for this one? So, just looking at the example here, you graph it, and then, so it's going to, let's see, it says you're going to press the math button, and then you go to solver, and it's going to do an equation solver. And you're going to put like an x placeholder up top for equation 1. So when you do the solver, you'll put your 1 to x, and then x squared plus 3 dx. That'll be equation 1. And then equation 2 is going to be 12. Okay. And then it'll help you solve for x. And it turns out that x equals 2, it looks like, once you plug it all in. Okay. So that'd be the way to solve for this last problem here for number 7. So the math and then solver button. And again, I don't have a calculator in front of me, unfortunately, so I can't look at it and make sure to verify that's exactly what it's going to say.
I got x equals, wait, never mind. I have to put in the bound. So what is the x value that we put in?
So you should be able to put, like, equation 1 goes from 1 to x, and then x squared plus 3x, you put the equation in, and then equation 2 should be 12. Yeah. Do you have to put it in like an actual bound? Like, I would say like -4 to 4 should catch it.
Yeah.
Let's see that. Oh yeah, no, that bound is fine. Yeah, that bound is fine. So that's
Good.
just that's saying from negative infinity to a positive infinity. So that's perfect.
Oh, so then it just says x equals 10.
Oh, so it is 10. It's 10. Okay, weird. I don't know. For some reason, it says 4 on the sheet. So, or it says 2 on the sheet. I mean, the solvers found that a equals 2. It's not written this sheet's not written very well at all, man. Usually
Oh no.
they're a lot better than this. Sorry, I did not look over this beforehand before I posted it for you guys. Okay, so you got a 10 though. Did anyone else get a 10 instead of a 2? I feel like it should probably be a 2 actually, because 10 seems like the area would be way too big. Yeah. So hopefully we got x equals 2.
Okay, wait, Lola, can you walk me through what you did?
Sure. So you do the solve. I mean, I just did the solver, so the same thing that you did.
Yeah, because I got 10, and I'm trying to think, like, because Lola just said in the chat that she got 2, and I'm curious how she did that.
Yeah. So, I mean, I think it might just be, can you show me your calculator? And you got x squared plus 3 in there. I mean, and you went from -1 to, yeah.
This is what I plugged in into, like, the actual equation solver.
Make sure it's a -1, not a +1 on the.
Oh, it's a -1? That's probably exactly why.
There you go, yeah.
Okay.
So, yeah.
I still got x equals 10.
Yeah, exactly. So Lola just did the thing for the last equation and you guessed. That's perfect. See, I like the guess and check method too. You just kind of, she did what we did in example 6 and she just tried like a number like, hey, let's try 1. So from -1 to 1 and the area wasn't 12. Let's try 2 from -1 to 2 and the area was 12. So she did a guess and check method, which would also work for this. All right.
I still got 10 and I don't know why.
Still got 10. Okay. I don't know why either. I'll try and work that out with you though after I let everyone else go.
Okay.
Your assignment tonight, guys, exercise 13C, problems 1 and 3. So here's problem 1. It's got 5 different problems to try on here. Just practice putting it into your calculator. And I want you to practice writing the definite integrals as well. So that's part 1. Write the definite integral down. That'll be something that I'm guessing you'll be asked to do on the IB exam, is just to write the integral and then find the area of the shaded region. Okay, so your lower limit, your upper limit, things like that are important. Let's see. For example B here, I can see on it right now that your textbook did not have an equation. Go ahead and cross out example B. Don't do part B on number 1 just because your textbook didn't give you an equation, so you won't be able to write a definite integral for that one. So cross out B. And then for problem 3, I give you a curve and it just asks you to do all these things. Find the zeros, which would be the x-intercepts. Find the point where the curve cuts the y-axis. All right. So hopefully we can do all of that stuff still. But for problem 1, cross out part B. We're not going to do part B on problem 1. That part's out. All right.